Recently there have been a lot of AI models launches. In their same sequence, recently GLM 4.5 was launched. So today we are gonna see what is it, how does like it compares with other models. So we'll read something about it, and then we'll try to use it with the basic block system. We'll ask it to create a basic block system and see how capable it is. We'll spend some time to understand the GLM 4.5 first. So let me search GLM 4.5. So this is a blog by, like, this is the official blog by z.ai. So we'll read through it. So basically they introduced two into their family, GLM 4.5 and GLM 4.5 that is the flagship models. 4.5 is built with 355 billion total parameter and 35 billion active parameter. So it has 355 billion total and 32, whereas GLM 4.5 AR 106 billion and 12 active. So it's a little like lesser model. Both are designed to unify reasoning, coding and agentic capability into a single model in order to satisfy more and more complicated requirement of fast rising agentic applications. There are, as such, in the market there are a lot of AI models available, and to do local development we often use Olama or some other systems. But one thing is that we try to put those model into our ID, but that doesn't work because the model needs to have agentic capability. Agentic capability means that they should be able to call external APIs and everything and work with them. So this particular model is agentic as well. It unifies reasoning, coding and agentic, all the three. Reasoning, like some of the models are good at reasoning, some models like Claude are good at coding. This model is trying to unify all the three into a single model in order to satisfy more and more complicated requirements of fast rising agentic. These are hybrid, so they offer thinking and non-thinking both mode in the same model. Like it depends on the company to company. Some companies are preferring to have thinking and non-thinking models separately. They have their own thought process, and this particular z.ai is trying to give both the models into one. LLM always targeted achieving human level cognitive capability across a wide range of domains, correct, rather than designed for specific tasks. Okay, as a good LLM model, it is necessary to deal with the general problem solving, yeah, and generalization and common sense reasoning and self improvement. In the past 5 years, OpenAI GPT-3 learns common sense knowledge and O1 uses reinforcement learning to think before respond. Okay, so it is giving some knowledge about earlier models as well. OpenAI GPT-3 have learned common sense knowledge, and O1 tries reinforcement learning to think before responding, significantly improving reasoning skills in coding, data analysis and complex math. However, the resultant models are still not very really general. Some of them are good at coding, some good at math, some good at reasoning. Yeah, that's correct. Like Claude 4.0 Sonnet is really good at coding, and some models are good at math and some good at reasoning, right? Like some models like Gemini 2.5 Pro is really good at reasoning, but none of them could achieve the best performance across all the different tasks. GLM 4.4 is an effort towards it. Okay, so they have given some overall performance comparison. We'll compare GLM 4.4 with various models from OpenAI, Anthropic, Google DeepMind, XAI, Alibaba, Moonshot, DeepSeek, and uh, 12 benchmark covering agentic reasoning and coding. So they are specifically targeting agentic reasoning and coding only, nothing else. Overall, GLM 4.5 is ranked at third place. So this particular model is just behind Grok 4 and O3 in terms of general model, having all the three capability. So as per this, Grok is really good at this, but as I have used it, I find Claude 4 really good at coding. So yeah, maybe they are trying all the three in one, so that's the comparison factor. But if we go into a particular one, this chart may differ. So if we are talking about general, all the three, reasoning, coding and agentic, O3 is top, OpenAI 1, Grok 4 then, and then GLM 4.5, and their GLM 4.5 air, which is like all of their models are open source. This model can run on high-end MacBook devices. So this particular one is I guess ranked 6th. Yeah, this is ranked 6th. So this particular one is, as we can see, it's already good, better than Claude 4 Sonnet. So yeah, and even Gemini 2.5 Pro. So that means this model is really good when comparing other models for local LLM. So we can consider this. This is beating QN3, Gemini 2.5 Pro, and even Claude Sonnet. So all the three it's beating. So as such, it seems really good bet here. Coming to agentic again, in terms of agentic, GLM 4.5 is second, which means we can use it for within our IDE for local LLM. It can give really good results. Reasoning, they are lacking in reasoning. So reasoning, as I mentioned earlier, like Gemini 2.5 Pro, I have tried myself. It's really good at reasoning. So as per their chart as well, Grok 4 is first and Gemini 2.5 Pro is second. Coding, when we are comparing coding, Claude 4 Sonnet beats everyone, and even in this case, this is not able to beat Claude 4 Sonnet. It is after that. Claude is leading in coding. If you see, Claude 4 Opus is the top one, and then Claude 4 Sonnet, and GLM is trying to catch up there. So overall, considering the open source model, this is really good. Agentic task, GLM 4.5 is a foundation model optimized for agentic tasks. It provides a 128K context length and native function calling capability. This is the capability that we were talking about earlier. We measure its agentic capability on bench BFCL v3, Berkeley function calling leadership, and on both benchmark, GLM 4.5 matches the performance of Claude 4 Sonnet. So GLM 4.5 is beating the agentic arena. So that's really good. Web browsing is a popular agentic application that requires complex reasoning and multi-turn tool using. We evaluate GLM 4.5 on the Browse.com benchmark, a challenging benchmark for web browsing that consists of complicated questions that expect short answers. Okay, with access to web browsing tool, GLM 4.5 gives correct answers for 26.4 of all questions, clearly outperforming Opus and O4 Mini High. Below the figure shows the first time scaling accuracy of GLM 4.5 on the Browse.com. So if we are seeing Browse.com accuracy, this page, test time compute, all the detailed result of different comparison models on three benchmark. So these are the benchmark. GLM is beating all of them. Yeah, all of them except this one, where O3 is good, it seems, whereas in other benchmark, all the three benchmark, it's beating. So yeah, they have correctly mentioned that it's beating this and close to O4 Mini High. Okay. Reasoning, so this was related to agentic. For agentic, they are really good. In terms of browsing, they are beating all the models in terms of all these three benchmark, TAU benchmark, airline, retail, and BFCL v3 benchmark. So that's agentic. Let's go for reasoning. Under the thinking mode, GLM 4.5 and GLM 4.8 can solve complex reasoning problems including mathematics, science and logical problems. So when we are considering this, we can see that 4.51 is yeah, really beating the bar here. 98 maths. O3 is good, but it's really close. This one, it has high, this is again high. O3 is somewhat good at some. So for the AIME and QAC GPQA benchmark, we report the average accuracy over 32 and 8 samples respectively to mitigate results variance. And LLM was used for automated answer validation. For the HLD benchmark, only the text based questions were evaluated with correctness judged by GPT-4. Oh, okay. So this one is interesting. We want this. GLM 4.4 4.5 excels as coding, including both building coding project from scratch and agentic solving complex coding task in existing project. It can be seamlessly combined with existing coding toolkits such as Claude Code, Code and Code Gigs. To evaluate the coding capability, we compare different models on SWE bench, verified and terminal bench. These two SWE is I guess from OpenAI itself. So when comparing this is 69, 70 and it has 64, which is really close. And then again we have 45 max and here we have 37. This is really close. For SWE bench verified, we use open hands this with run limited to 100 iteration and history truncation to prevent exceeding the 128 context limit configured with temperature 0.6 and top P is 1. For terminal bench, we use the terminus framework for evaluation. We use standard function calling rather than direct prompting for evaluations. Okay, we conducted a Pareto frontier analysis for all the comparison model as illustrated in the figure below. GLM 4.5 here demonstrates superior performance related to models of comparable scale and achieving optimal efficiency on the performance scale trade-off boundaries. So when we are comparing SWE benchmark verified, it's beating the QLM model parameter. These models are really having a very large model parameter. This is beating even with a smaller parameter. It is in the top notch. We have Claude 4 Sonnet and Kimi K2, Gemini 2.5 Pro, GPT 4.1, but all of them, okay, they have unknown model parameter that is not known to anybody, so they put here. But overall with the limited model parameter, this is performing really well as compared to QN and DeepSeek as well. GLM 4.5 demonstrate comprehensive full stack development capability, enabling seamless creation of web application that encompasses front-end implementation, database management and back-end deployment. The front-end interface generated by GLM 4.5 exhibit enhanced functionality and aesthetic appeal, demonstrating strong alignment with human design preferences. Furthermore, exhibit superior performance in generating presentation materials, including slides and posters. So they are, as per them, they are good at generating slides and posters as well, with capabilities significantly augmented with integrated with agentic tool for information retrieval and contextual enhancement. Okay, GLM 4.5 experience with agentic coding in real world development scenario. So when comparing GLM 4.5 with Claude 4 Sonnet, Claude 4 Sonnet, it loses with 50%. With Kimi K2 and Q3, this is winning. So the closest competitor that it has right now is Claude 4 Sonnet, as discussed earlier as well. To assess GLM4 agentic capability, coding capability, utilize Claude Code to evaluate performance against Claude 4 Sonnet. Kimi K2 and Q3 win Quen 3 coder across 52 coding tasks spanning front-end development, tool development, data analysis. So they tried front-end development, tool development, data analysis, testing, and algorithm implemented. All evaluations are performed in isolated testing environment through multi-round human interaction with standard evaluation criteria to ensure consistency and reproducibility. The empirical result demonstrates that GLM 4.5 achieves a 53.9, roughly 54 win rate against Kimi K2. Yeah, same thing. It's while shows competitive performance, further optimization opportunity remain when compared to Claude 4 Sonnet. It's lacking against Claude 4 Sonnet, but winning against every other models basically. Average tool calling success rate, in that it's even beating Claude 4 Sonnet. Average token usage per interaction, Claude 4 Sonnet is using roughly 1.5 million, I guess, and Claude 4 Sonnet is using very less token per interaction. So they are using more notably GLM 4.5 achieves the highest average tool calling success rate and outperforming even Claude for Sonnet, and this demonstrating superior the trajectory for all coding tasks are publicly available here. Okay, they have given some demos as well. GLM 4.5 enhances the complex code generation capabilities introduced in April release of GLM 4. The model now creates a sophisticated standalone artifacts from interactive mini games to physics simulation across HTML, SVG, Python, and other formats. These improvements deliver superior user experience while laying the foundation for advanced agent coding applications. Okay, so here they have tried to create Flappy Bird game. So Flappy Bird game, we can see it here. Let's test. So write a Flappy Bird game for me in single HTML page, keep the gravity weak so that game is not too hard. Okay, so they have tried to create. Okay, overall this is looking good. Even like let's see the code as well. In terms of code, we can see game container, game US, core, start screen, game canvas, game container, game US, core, base core. Overall code is okayish type. JavaScript piece looks good, whereas CSS can be like improved in terms of quality, like how they are naming things and how they are writing code. But overall, it's really good. So let's try the other piece, slide creation, leveraging GLM 4.5 powerful agentic tool uses and HTML coding capability. We developed a model native PPT or poster agent user can request. Okay, let's directly jump to this piece. They have tried to create a slides. Overall slide is also good. It's good. So let's try other one. So this is slide. Next, this is interesting. We want to explore this. GLM 4.5 excels in both front-end and back-end development, making it powerful for modern web development. To better demonstrate its capability, we develop a coding agent inspired by Claude code by providing a basic full-stack website boilerplate. The agent enables user to create an entire website with just a few words. User can effortlessly add feature and refine their project through multi-turn dialog, making the code process smooth and enjoyable. Just relax, let this do. Okay, let's try this full stack project. So it has tried to create a project here. let's click this, say this is a full stack project. Okay, if we can do something here, can we search I say you are, what if I say fairy and I remove this? Okay, overall looks good, it's quite fast as well. So we can now move on to the next piece and see. Getting started with GLM 4.5, chat with GLM 4.5 on this, call GLM 4.5 API on this, offers OpenAI compatible interface. Yeah, GLM 4.5 with coding agent, detailed instruction for integrating GLM 4.5 with Claude code and other coding agent frameworks are available at serve GLM 4.5 locally. Model wait for both base and chat variants of GLM 4.5 and AIR are publicly available on Hugging Face and Model Scope. For local deployment, GLM 4.5 supports inference framework including VLM and SGLang. Comprehensive deployment instructions are available in the official GitHub repo. Techniques, model architecture and pre-training. So these are some details. Maybe we can spend 5 more minutes to read through it. We can have some learnings from this, maybe how trainings are done and pre-trainings are done. Okay, techniques, model architecture and pre-training. In the GLM 4.5 series, we adopt the mixture of expert architecture which improves the compute efficiency of both training and inference. We employ loss free balance routing and sigmoid gates for model of mixture of expert, I guess, mix of expert. The layers, unlike DeepSeek v3 and Kimi v2, we reduce the width, hidden dimension and number of routed experts of the model while increasing the height, number of layers. Okay, we reduce the width, hidden dimension and number of routed experts of the model while increasing their height, as we found that deeper model exhibit better reasoning capability. In the self attention component, we employ grouped query attention with partial ROPE. Furthermore, we utilize 2.5 times more attention head. This counterintuitive. While this increased head count, it does not improve the training loss compared to the model with a fewer heads. It constantly enhances the performance of reasoning benchmark. For we utilize the muon optimizer, which accelerates convergence and tolerates a larger batch size. We also incorporates QK norm to stabilize the range of attention logic for both GLM 4.5 and GLM 4. We add a multi-token prediction layer to support speculative decoding during inference. General pre-training corpus is 15 trillion in the pre-training, and then code and reasoning continual pre-training corpus 7 trillion. Okay, and then mid-training repo level code data 500 billion, and then synthetic reasoning data 500 billion, long context and agent data 100 billion. That is to check 32 context, that is 500 billion, 500 billion, 32k, and then 128k. Our base model undergoes several training studies during pre-training. The model is first trained on 50 trillion tokens of general pre-computing corpus, followed by 7 trillion tokens of code and reasoning corpus. After pre-training, we introduce additional stages to further enhance the model performance on key downstream domain. Unlike the earlier pre-training stages on large-scale universal document, these stages leverage medium-sized domain-specific database. And just to basically add to a context, here there was mentioned that we reduced the width of the model while increasing the height. With this, what do they mean is in this basically all the models in the AI world, neural network, basically there is only one algorithm that is in the play, which is called neural network. You can explore more on that. In that basically it works same as our mind. So there are different layers of basically there are different layers, and at each layers there are different neurons that are sitting there, something like this neurons sit, and each neuron are basically capable of something, or they are basically we can say they have a memory. Basically they can learn from things and then retain that learning. So from here we push the input that goes through this different layer, and each layer learns and improve their weightage. So they here basically weightages are assigned at each model. So basically they learn through weightage only. So this is the basic neural network approach. In this they are mentioning that they have reduced this, that is number of cells at a particular layer, and increased the number of layers. With this they are trying to basically achieve this. So let's move to final piece. Will RL for large scale models with slime. Okay, so they have some architectures in train data to Megatron and data buffer. So Megatron updates weights from distributor tensor, SGLang servers, SGLang server, SGLang router, any custom data generation, custom rollout generation, and then it goes and continues. So this is data to facilitate the highly efficient reinforcement learning training required for large scale models such as this. We have designed, developed an open source slime. Oh nice, they have created slime as well for highly efficient reinforcement learning. There is RL infrastructure engineer for exceptional flexibility and efficiency, scalability, and we actively encourage community use and conversion. Slime's primary innovations are architected to overcome common RL bottlenecks, and particularly in complex agentic tasks. Flexible hybrid training architecture. Slime's core strength is its versatile hybrid architecture. It supports both synchronous co-located training and ideal for traditional like reasoning, and this as well as disaggregated asynchronous training mode. This asynchronous paradigm is critical for advanced agentic RL where data generation can be slow. Decoupled agent oriented design, accelerated data generation with mixed precision, post training with reinforcement learning for agentic capability. So expert training goes this, and then unified training GLM, and this. So this process. So overall they have done really good job. They have open source slime, their model for reinforcement learning, and they have a really good trained model out there. So this was their research. We have gone through it to understand how they basically compare with other. Overall, like as we saw, like they are third in terms of agentic reasoning and coding. And when talking about coding, they only lack with respect to Sonnet or Claude models, whereas reasoning and others they are basically agentic one, they are really good at. Reasoning they lack a bit. So this, they have basically improved a lot on the agentic piece. Reasoning and coding still lacking, but coding is quite a good. So overall good model, we can try. In the next video we'll explore we'll basically try the full stack approach if we are able to develop block system with it. So that is all in this video. Thank you for watching. Thank you.